Hello, my name is Barry Evans with Penn State University. In this unit, we'll be talking about using MapShed to create a project. In this context, a project is essentially a compilation of different data sets that are used to prepare an input file for the GWLFE watershed simulation model. For the activities we'll be conducting in this unit, we will first use the project manager to create essentially a blank MapShed project. We will then load different data sets into the view in MapShed and then save these data sets in the project for later use. It probably bears repeating here that everything I'm going to be discussing for this unit is also covered in the MapShed User's Guide. In particular, today's activities are covered in Section 2 of the manual. To create a brand new project, we first click on the MapShed icon that was installed as part of the installation process discussed in a previous unit. At this point, you are presented with the project manager, and you have two options. One is to open an existing project, and I have created a number of projects over the years. However, for a new project, for new users, we want to build a project. We first enter a name. Since we will be using some demo data, I think maybe the best choice is to call it demo. We then say build. This basically creates a copy of a MapShed window, which is opening up now. This is blank. We can expand this, and then the first task is to load data. Again, we are going to be using some of the data sets that we downloaded in the demo data download installation that we did in the previous unit. Shown on the screen is a form called the Load GIS Data Layers form that is used to identify the different data sets that will be utilized by MapShed to estimate the different model parameters for the GWLFE model. How this is used is to click on the Browse button along the right-hand side, browse to a layer or a data set, and then load it. This form is used to identify both the name and the location of those data sets. Essentially, what's done is a list is created that can then be saved as what is called a source file or a .src file, which can be used later to load data automatically if needed. Now, as can be seen in this form, there are both required layers and optional layers. Required layers are those that are absolutely necessary in order to have MapShed produce an input file for the GWLFE model. Optional layers, although not required, if available, they can provide a better estimate of various model parameters than by not using them. In Pennsylvania, we have developed a number of required layers and optional layers for the entire state, and we will be loading some of these for use in the next unit. So we can begin this process by first loading the basins layer. We click on the button, and we then browse to, in this case, we're going to go to the demo data folder that we had installed in a previous unit. So we will load a shapefile called Spring Creek. A shapefile is an Esri formatted file. We can also use grids in MapShed. Basically, Map Window allows Esri formatted files to be used for processing, and we have decided to use this format for MapShed. Other formats, however, are available. For information on Esri formatted data sets, layers, including shapefiles and grids, please see Section 2 in the MapShed User Manual. The next layer we are going to load is a DEM grid. DEM stands for Digital Elevation Model. It's essentially a raster data set of topographic values. We'll load that by browsing again to the MapShed demo data folder. Click on DEM30. An Esri grid essentially has two parts to it: the layer name and an info file. We load this by clicking on the layer name and then this STA file. You can see we have a DEM STA.adf. That's one of the files that comprises an Esri grid. We then load the Landuse. We can back up to demo data, go to the land cover folder, click on that, open up the land cover folder again, and then double click on the STA. We're now going to load a soils shapefile. Again, this is in demo data. It is called soils. Next, we will load a streams shapefile that has already been prepared for this watershed that we're working with now, which happens to be called Spring Creek. And by the way, this is located in central Pennsylvania. So here is the streams file. Now, I've been double clicking before. We can also just highlight it and say open. It does the same thing. Next, we will be loading a weather data set. This is a shapefile that contains locations of different climate stations. In this case, there are only two that we've identified, but there are many located throughout the state. The next thing we're going to open, or at least browse to, is a weather directory. This is a folder that contains weather data, that is daily weather data, precipitation, and temperature. I'm going to click on the Browse button, navigate to the weather folder. In this case, we can click on any one file in this folder, and in some cases there may be 30 or more weather stations. All we need to do is click on one file to establish the link. So what this does again is it just shows a path. A path name is saved that can be used to get weather data later on. Now we will also be loading some optional layers and including something called Soil P, or Phosphorus P grid. This is an indication of the amount of soil phosphorus, and this can be saved as both total and soil test P. In Pennsylvania, we typically use soil test P unless you've created your own, which might be total or soil test P. Again, the manual describes how these different data sets are created and how you might create your own. In Pennsylvania, these data sets have already been developed, and those are the ones that we'll be using for this unit and other ones later on. So browse to this one. Again, demo data. So P, something called soil phos, and that STA folder. We'll next load something called groundwater N, which is an indication of the background groundwater nitrogen levels across the state. This is in the GWN folder. Double click on that. Double click on GWN back, which stands for background groundwater nitrogen. And again, double click on the STA file. Physiographic provinces is a shapefile that's used to hold different types of information. That's located in this physprov. Double click on that, load that. We do not use the septic systems. We do use the counties layer, which has some additional information related to erosion as well. Double click on a county. We also have an unpaved roads layer. We can navigate to that, and that is called unpaved, not roads, but unpaved. Again, I'll just highlight this and say open. It's also possible to use other layers like a water extraction layer, an APHOS, or an animal feeding operation layer. Some of the other ones we will be using in a later exercise, but these are the only ones that we will be using to use in the next unit. When we're satisfied that we've chosen the correct ones, and by the way, we can go back and eliminate any one of these to load them again. For example, if the Spring Creek one is not correct, I can zero that out, go back, and load that again. Now, I can choose to use these check data layers or check layer alignment options. This is only done if you've created your own data set and you're not sure if everything is in the same geographic projection. Again, in Pennsylvania, everything has already been prepared and everything has already been done correctly to align correctly, so we don't need to do this. At this point, when we have identified all the data layers that we think we want to use, we then say OK. It says you want to save these changes, and for the first time you always say yes. So we are going to save this. As you see, it's going to be a .src file. We're going to save it in a particular location. It can be anywhere you want. I've already saved one before as a result of an earlier run called demo. I'm just going to save it on top of this. It says there exists, you want to replace it, and I would say yes. You would not necessarily get that if you did it the very first time. So what's going on now is that MapShed is reading that source file and is loading all of the layers that we'll need to generate an input file for the GWLF model. To show you what some of these things look like, I can click on the unpaved roads here. There's stream layer here. There's a soils layer there. Physiographic province. This is a groundwater nitrogen layer. These values here indicate different levels of nitrogen concentration in parts per million. This is a soil test P layer. These are values in parts per million as well. These have already been estimated using some other procedures and again developed for the entire state. This is a digital elevation model. These happen to be the elevation in meters. And this is a land use map. Again, this has been done for the entire state, and these are the different land use categories that are included in this map. Much more information is included in the MapShed User's Guide on how these data layers were created and what they mean. And if you're interested in that, please go back to the appropriate sections in the User Guide and read those. At this point, we have got everything loaded and we can save this. This is done by going to the Save button here. This saves the project. What this means is that I can close the MapShed. I can reopen it. This has now been saved as a project, so I can now load it in a project that's, this is something that's already been developed, and I can load this without having to go through the process of identifying all of those different data sets that are used. And so here we have the same screen that was shown before. This concludes this particular unit. In the next unit, I will describe how we actually select one or more basins and initiate process to create the input file for the GWLF-E model.